Good morning, all. I'm Chandan from Sigma, and today the topic of the discussion is AI-based maintenance. Since you're part of this discussion or webinar, I think you are somehow associated with maintenance in your current role or in the. So I would consider you're a kind of expert in that, and then you understand the basics of day-to-day maintenance at your place, at your workplace. So today we will focus on the other aspect or Industry 4.0, that is the modern terminology where maintenance is given a is done in a new way, and it is we make use of artificial intelligence and machine learning to come up with the efficient maintenance strategy and schedule that would be saving you cost and improving the asset availability. And today's discussion would be focusing. There are a lot of tools in the market available that provides AI-based maintenance, but today we are going to discuss about this Maximo application suite 8.x and how to do that in this with this application. And the agenda for this session, let's see how much we can cover, but it's a really short time for this such a broad discussion, but let's try to get basically introduced to it. That's the best that we can do. And in case we need some detailed discussion, then of course it would be possible to plan in future. So we talk about AI-based maintenance. We hear a lot about IoT, AI, machine learning, augmented reality, all these things. So let's talk a bit about that, and then why do you need to do this? All of us have been doing maintenance for ages now, and I think we have done quite good. But this is like a future that future of maintenance looks like this, and it will be backed by AI. So what are the benefits of doing it? So we will take a look into that, and how do we do it all together with MAS? So how does this tool or the product offering from IBM helps you achieve that in like everything in one box, basically? So you can do a very nice setup and do the AI-based maintenance. We will try to deep dive into a typical maintenance scenario from the shop floor. And when you have a tool like MAS or basically MAS, then how all different components of MAS come together in picture and exchange data and helps you beat the end objective. Then we talk a bit about the brand new deployment scenario. How will somebody go for MAS from scratch, like you're phasing out some legacy system or that kind of stuff and deploying it for the first time? Or then the second scenario is that you deploy it with your existing system. It doesn't always have to be Maximo. You can deploy MAS to be used with your existing maintenance system, and it can be non-Maximo as well. Because Maximo is just one component in this whole offering, in this whole bundle of products or suite of applications. And then we talk a bit about if you plan to go for a POC, what would be the way how we can approach it. And there are some misconceptions or since Maximo is released almost every year with some new feature and it gets a new version number. So when we saw MAS 8, there was a misconception that perhaps this is like a new version of Maximo out in the market, and then customers started to explore that how do we upgrade to that. But just to clarify that MAS 8.x, that is the current version is 8.2, I think. It is not equal to Maximo 8. This is something different. So Maximo is just a component inside MAS bundle, and it's not a next version of Maximo. And also, since it says that Maximo application suite, it might give a perception that, okay, this is something that you can use only with Maximo, but that's not true. You can use these smart AI components like predict, monitor, and those things with your existing asset management system as well. We have to look into the technicalities, but I think most of the systems would comply or like will be in a position to connect with this MAS bundle. So moving on, since we had some, I looked at the email ID of attendees. There were some people from university as well. So in my understanding, you can put AI-based maintenance like this. So you have one or the other kind of system where you have been doing maintenance. So you have collected a lot of maintenance history data, and data is a real important thing. And this is more, you can see that the history data that you have collected has a lot of information that you should exploit and try to basically establish a pattern how your equipment have been failing, a particular pump or particular machine on the shop floor, and it can also give you the type of work that you have been spending your money on. So there is a lot of insight that you can get from this maintenance history, but like you need some kind of analytics capabilities to find that out. So in AI-based maintenance, maintenance history is one component. So we connect these models with this maintenance history and learn from the failure patterns in the past. And then we have we get some data from the real-time data from the sensors that you have mounted on your machines on the shop floor, like vibration sensor, then heat sensor, all those kind of different sensors that would provide you the real state of your machine, that what is happening on there, that you would usually notice when you see that, okay, there is a unusual vibration in this machine, or it looks like it is overheating. Then you would ask somebody to go and check if you feel suspicious about that. Or then in the worst case, you would notice it only when the equipment has already failed. But when you put a sensor on it, it can feed the real-time data, real-time reading about the vibration, and you can also configure it like to report you the reading only when it goes beyond the threshold that you specify. So maintenance history, real-time sensor data, and then there is weather forecast. So we put all these three together and we feed it to the AI and machine learning module in Maximo, in this MAS suite. And then it has some inbuilt models that can help you to get the outputs like analytical insight. You would be able to really find out what you have been doing in past, and based on that, you can do some kind of asset health scoring. So you can take some sensor information, then some data from here, some data from weather, and then put them together and make a formula. And based on that, you can give a score that if these parameters are like, then this is the score or health score of my asset. And so that will be like a analytical insight that it will give you. And also there are a lot of other things that you can extract from your maintenance history. So this analytical insight, and there is a predictive model also in this one. So all these things are fed to the predictive model, and the model, and after a while, it is ready to predict you, or it will give you a percentage that what is the chance of failure for this particular equipment. So that it will provide, and it will basically predict the failure. And end objective is that we will repair the machines only when there is a high probability of failure. Right now, we are doing the maintenance based on manufacturer's recommendation, or like you have to do this after every 3 months or after every year or these many running hours. But by using AI-based maintenance, you are going to do it, or we basically try to achieve a point that we repair machine only when it is about to fail. So then in that case, we are saving some money by like overdoing the maintenance. That is the main benefit of this. And in MAS, all these components, they all bundle. Like maintenance history comes from your EM system. There is a platform, IoT platform integration supported. So you can get the data from sensors directly. And weather connection is there. So you can get some weather info also from Weather Channel or that kind of website or some weather provider. And everything together, and then finally you will be able to, or basically system will suggest you to take action, that what you should do now. And there is one step further here. When Maximo has, or MAS has suggested you to take some action, it can also help you to uh, to tell you that how to do the certain work that it has recommended, and that is the assist module in this. So it can assist module, basically you can type a natural language question to that. Okay, this is broken, how do I do that? So you type in your question, and then it will try to find out all the history cases in the past. It can go and connect with your supplier manual and all sort of different things, and give you a on the spot recommendation, or helping you with the diagnosis and fixing. So this is how a typical AI-based maintenance scenario will look like. Of course, there are a lot of finer details that we can talk about, but in simple terminology, this is how AI-based maintenance would look like. Moving on to the next one. Yeah, so this is the evolution of how Maximo has evolved as a product over the period of time. So EAM Foundation, here there was only one, basically Maximo. It was helping you with the schedule maintenance and planning, and you can do running hour-based maintenance or condition-based maintenance. So basically, it was a standalone system that had a lot of capability that you can configure and use to do the normal maintenance tasks that you would do. Then the next step was that it started to provide you a connection with your IoT platform, so you can feed in or get the data from your sensors on the field. So this is the stage where Maximo started to connect with the IoT platforms and get data from there. Then the next step was that all this data and everything can be put together, and they started with the health scoring. So based on that, you can see which asset is performing really bad and which asset is good. So that way, based on the health score, you could give more focus to the asset that really needs. So you would be analyzing in detail, okay, what is going wrong for these assets that are in red, and what needs to be done. So you can put more focus on that. And that was the health component. And then the next step was that predict. So we started to build the predictive analytics models based in SPSS. And these predictive models will basically take data from sensors from here, and then put them together, and the prediction algorithm will try to predict what is the probability of failure of the asset. It wouldn't be like that, okay, if you keep your machine running for next 100 hours, on 101st hour, it's going to fail. It's not like that, but it just gives you a probability of failure. And if you see that if probability of failure is like 90% or something like that, then you can start taking an action on it. That, okay, it's time to do something there. And the next step is prescriptive maintenance. Basically, here it helps you with the diagnosis. These days it's a big problem that all the experts that have been working in the factory for decades, many decades, they are about to retire, and then the level of expertise that they have acquired over the period of time, it's not present in the new guy who joins the team, and he doesn't have anybody like very senior to help him with his job, or basically train him. And if so, in that case, it takes too much time to train those people, and of course, also it will be very, very costly and time consuming to fix equipment. So this assist module here, it has come up, and it basically does is that it tries to bring the expertise that the human had on the shop floor. So you just type in the question, and then of course it will go to the history and see if there has been a similar failure in the past and how it was fixed. So the technician can learn from that and try to diagnose it based on that. Or then it can also look into different sources on the internet if you're connected with that, or then a lot of set of manuals that you have on the factory. So it can connect with that and try to give you or recommend you some ways how to do that. So that is the stage where we are right now. And in MAS, all these components are working together in a great synergy. So you will really see a working solution with everything, all the functional components. Moving on, why do you need to do the AI-based maintenance? And also, I have in the coming slides, I have some screenshots how these details look like, so we can have a look, just to give you a glimpse of how this system looks like in the end. Then why AI-based maintenance? I think most of you already know this. The end objective is to reduce the failure and increase asset availability. And every point that you see here basically translates to improved number for the organization. So you save the money in maintenance, that basically is really kind of a profit that you can invest in basically invest in a lot of things in the factory, like buying some smart machineries or improving your production capabilities. So reduced failures, that's the main aim. In the end, it should be zero failure. Basically, that's the target that we are trying to hit with all these kind of smart things, where we try to predict the failure. So there should be zero failure, or basically zero unplanned downtime for the system. So that is the end objective. Cut down unnecessary preventive maintenance and reduce maintenance cost. Sometimes I've seen with few customers that they have a schedule that their engine needs to be overhauled this period, like 6 months or 1 year. So of course, the type of maintenance that you do on the engine after a certain period, or like 6 months or 1 year, varies. Number of tasks that you perform in 1 year maintenance is going to be different from what you do in 6 months. So sometimes it happens that when the expert look into the engine components, they feel that, okay, it's really still in good condition, you don't really need to do anything, and then they can make a decision to postpone that. So that somehow proves that the preventive maintenance strategy that companies have right now has a chance of improvement. So there are some we are doing maintenance when it's not really needed, or we are overdoing some maintenances, where you still have possibility that you can run without failure for next 100 hours or 500 hours. So that running time of 500 hours, if you cut that down, that's going to save some money for you. And that we try to achieve using AI-based maintenance. Analyze asset failure pattern, focus on the right set of assets. On the shop floor, there could be thousands of assets or thousands of machineries that you are responsible for as a maintenance team. So, and end objective is to meet zero downtime, zero unplanned downtime, or zero breakdown. So you got to be really focusing your energy on those assets which really need it. So this health scoring is going to help you with that. That you focus on all those assets that is performing really bad, and plan set of actions for that. Then extended life of asset. Every breakdown has its own impact. So if you are maintaining it really on time, that extends the life of asset. So that is one advantage. Then increased production output. That's very obvious, because if you have unplanned downtime, then you will have the production will be happening all the time, and there will be minimum outages in the factory. Improved diagnosis, like I said about the assist, it helps you with the fast diagnosis and maintenance of your asset based on its searching capabilities and natural language understanding. Then improved field engineer productivity. This asset suite, application suite, has a mobile application, and it is powered by this assist component. So when somebody is repairing an electrical tower many kilometers away from the main head office, or where they have all the people sitting, so on the field, if they find that, okay, something is not working and he really needs some help, then he has to drive back if needed, and then that's going to consume a lot of time. It's going to become very costly to come back and get the stuff and go back. But if he's available on the field with a mobile device, and he can use assist, or then he can ask for a remote assistance directly from the head office. And there are many more such advantages that really AI-based maintenance provides. Moving on. So what is there in MAS? So you see there are different components here. So these are different components that comes with MAS, and it is available as containers on Red Hat OpenShift platform. So if you are using on-premise model, or you are running your maintenance system in a cloud, these are very execution environment independent. You can run this on-premise, hybrid cloud, or any public cloud, and it's very easy to migrate because of container technology that they are using. And licensing has been really flexible in this. I think you would have, if you were participating in the last IBM webinar, there was some insight about that. And we have experts that can help you with the licensing entitlement and how it works basically. So a quick introduction to different components. So manage is your Maximo, or your asset management system. That it can be Maximo or non-Maximo system. If it is not Maximo, then it will be connected from outside. The scheduler, it's a component again based on Maximo platform that helps you with the planning. Monitor gives you the health scoring part based on the formula that you design, taking into account the historical patterns and sensor data and everything. Monitor is like you can see the parameters related to the asset, and health is going to give you the scoring. Predict makes use of all these things together and predicts the failure. And then in the same suite, you have a mobile solution as well that you can use. And this is very handy and very useful, very popular these days, that having a mobile application for maintenance. Then assist is a natural language processing capability, natural language understanding module that helps you with the diagnosis and things. Safety is again a Maximo extension that focuses or specializes on safety, things like permit and lockout and tag out, and then root cause analysis, all those things. Visual inspection, there is a component that has a very high resolution camera that can look on your production line, and if there is any kind of anomaly, it can detect it and flag it that, okay, some product has a minor crack, or like, let's say, for example, a tire is there, or there is some kind of crack in it that with bare eyes, you might not be able to notice it. And then there are industry accelerators. These are basically your different, like, maintenance needs for each industry is not same. So oil and gas works in a different way, and nuclear power has its own needs. So Maximo has got industry-based solution that you can deploy on top of Maximo as an add-on. So this is also related to Maximo. So that is how to do it with MAS. All these components work together and achieve you AI-based maintenance. Here I have tried to connect, so you will get the PPT somehow, and you can see which component here, like maintenance history, is going to be fulfilled by manage component in MAS. So that kind of mapping I have provided here. Basically, I'll skip this one. Then this is the roadmap, how we plan to, or how MAS is planned to release different components. As of today, there is not all the components that you saw in the earlier slide is available, but very soon, one by bringing it in. Like in Asset 8.3, Maximo will be there in that bunch, but it's not there until 8.2. So they all are coming one by one as a container, of course. And of course, there must be some plan going beyond this as well. And for those who doesn't know about Maximo, it's really a very configurable tool, and it's a world leader in asset management system, if you refer to the Gartner Magic Quadrant. And it has been there for many, many years, at least since I started my career until now, it has been there in the leader quadrant. A typical maintenance scenario, like I suspected, we will run out of time, but let's quickly go through this. You have on one fine morning, you see that, okay, my pump is working really nice and the health score is fair. That's how the day starts. And then somebody goes there and he does a manual inspection. Maximo has a component for manual inspection as well, that you can take a handheld device and you have set of questions that you're going to do the inspection with, and maybe take some photo and upload meter readings there. So once the meter reading is uploaded, inspection is complete. System finds that, okay, it has got some issue with the temperature and pressure. So the system as soon as it gets the meter readings on the monitor panel, is going to show you, okay, it has got some problem and health score goes down to poor. And of course, it has the IoT and weather data as well. So sensors are also feeding continuously and contributing to the health score that you will end up with. Then the next step is alert. So it shows some alert, and you have there is something called condition monitoring application in Maximo that will get the alert and it will automatically create a work order. Like basically take an action if you have defined it in the system that, okay, if the health score goes below this one, or if there is an alert like this, then you automatically create a work order. And work order is created, and there are workflow supports that you can automatically channel that workflow to the right group who is going to look into it. Or then you can send it directly to the engineer who is on the field, and he will immediately see that, okay, there is a high priority case or critical case that he has to look into on his handheld device. And he goes and starts to diagnose the issue of what is going wrong here. And then on the field itself, if he is not aware about, okay, this is the problem, then how do I fix it? Because he's a new guy, he doesn't really know how to go and address this issue. So he can take help of this assist tool and type in his questions there. And I think it supports Finnish as well, as I remember from last IBM meeting. So you can type in your question on the panel, and then it will give you some repair guidance. If you're looking at the solution, if you're convinced, of course, you can go ahead and complete the work. And then after that, asset health score is back to fair. So everything is normal. Just imagine coordinating these things, how much time it will take. A lot of time before you basically reach this complete stage. But in this case, since all the modules are working interconnected with each other, it really works nicely, and very soon you will be able to fix the asset before it really fails. So that is the advantage of having a maintenance supported with AI and predictive models. These are some screenshots from the component. So this is giving you scoring detail. There are, just to mention that these things are already pre-configured in the system in case you want to use it for POC, but of course it gives you flexibility to design scoring system and everything based on your understanding and your formulas. So these are not hard coded, these are configurable. Everything basically you can change here. Then weather forecast, you can see how the weather looks like in coming days. Then the meter reading, what has gone wrong, and these trendings really help, like how it has been deteriorating over the period of time. And then this is the module or application Maximo, which is responsible for creating the work orders. And here you see the predictive maintenance part. And you can either manually take an action or create a work order, or then you can let the system do it automatically for you. And this is the seek advice module from Assist. You type in your question here, and then it just gives you all the related works. I'll look into how a new deployment scenario will look like. So if you are having a system that is non-Maximo, or if you have an older version of Maximo and you would like to upgrade to Maximo Application Suite 8, then it is going to be a new deployment where we will deploy this container environment, and it will be very easy to then upgrade the Maximo here somewhere outside and connect the database inside the container, and everything will be fine after that. These modules are optional. It's not mandatory that you have to have everything running. Run only that you need and you feel relevant to your business. So in this case, a typical new deployment scenario will be you're upgrading from current Maximo version, or then you have some kind of legacy system or a non-Maximo system that you would like to phase out and go ahead with MAS and Maximo as your enterprise asset management system. I will rush a bit because we have less time, and we can open the discussion. Then deployment with existing system. Like I said in the beginning, there are some applications here that basically need Maximo as a base to operate on. So this will be your current EAM system, and we can build an integration with this MAS. It can be anywhere, IBM Cloud or AWS or Azure or anywhere you have your system hosted. That is not a problem. We can deploy this and make an integration, and you can take help of all these modules. This will be functional, but all those that you see with the red background here, they need Maximo as a base solution, so it won't be available in that case if your current EAM system is non-Maximo and you don't plan to change it. And then take the first step. I would say that everything starts with the first step, and it might sound like it's too much if you see everything in one picture, but generally how customers go for AI-based maintenance is that you identify one group of asset or like one production line or some specific type of asset and try to start to monitor that using this MAS suite. So identify asset or group of assets, then you will be, if you don't have the sensors there, you can, I would suggest that it's good to have the sensors there, at least few sensors just to understand how this whole story works. So your maintenance history and sensor data and weather info, that is optional. You can, if you want, you can connect it. Or if weather doesn't really make any difference to your operations of your asset, then it's not needed, it's optional. We will feed historical maintenance data and then get real-time asset health insight. And then all these things will be sent to the predictive model that already exists in the out-of-box solution. Or then if you have some capabilities or need, then we can build a new SPSS-based predictive model and try to train that, and then that we will see that how it works in predicting the probability of failure for the assets. But yes, having a maintenance history is very important because that's where the system learns the failure patterns, and it will be a very valuable insight to predict the failure. We as a Sigma can host the POC environment, so you don't have to worry about setting up OpenShift environment and Linux environment and then having all these containers. We can do that part. You just have to provide your maintenance history, access to your maintenance history data and sensors from your machine, and we can connect them together and see this working. So if you have the will, then we will find a way for it. So that is how I see that. Yeah, that was all that I had in my slide deck. Now we can